Welcome students. We are going to study today Boolean Algebra as a topic. This topic comes for 5 marks in board exam. If we are lucky, it will come for 8 marks. I suggest this is one of the easiest topic of the section A. So let us start this topic, Boolean Algebra. When I was a student, my teacher used to teach me this topic as, students, now let us see how this topic is algebra. What do you mean by algebra? Then after 15 minutes, now I am going to teach you what is Boolean algebra. So by the time the main important part of the topic comes, where is the application of the Boolean algebra, we all get lost. We are going to study this topic from the application point of view. Okay, so throughout this topic you have to make sure certain notations. Throughout this topic we mean plus as switches are in parallel. Dot means switches are in series. For parallel circuit, I hope all of you know that parallel circuit means this. Series circuit means this. We say 0 means switch is off. And we denote it by this, that means to indicate that there is a break in between. 1 means switch is on, and I will denote it by this. That means yes, if you supply current here, then current is reaching here. Whereas in off switch, if you supply current here, there is no way it can reach here. We need to design few properties for doing this topic now. So let us see what do you mean by 0 plus 0. Now this is not a decimal system 0. This 0 means your switch is off. Now let us see, we have a 0 switch, that is off switch is connected in parallel with another off switch, and the combination will look like this. Let us see, if you supply current here, will it reach here? There is no way it can reach because both of them are off. So if you supply current here, it will never reach here. That means together this combination is going to act as 0 switch itself. Let us see what happens to 0 plus 1. Now you have a 0 switch, off switch is connected to a on switch. If you supply current here, it's going to reach here by this way. So 0 plus 1 is going to be 1. Similarly, 1 plus 0 is going to be 1, and 1 plus 1. Now suppose we have on switch connected to on switch. If you supply here current, if you supply current here, it's going to reach here. Okay, because of the Kirchhoff's law of current addition and subtraction. So 1 plus 1 is not going to be 2, it's going to be 1 itself, because current is reaching 1, and whenever current supplies, you write switch as on switch. Let us see what happens to 1 dot 1. Now here dot means switches are in series. Okay, so we have on switch connected to another on switch, and let us see the current. If you supply current here, will it reach here? Yes, it's going to reach there. So together 1 dot 1 is going to be 1 itself. 1 dot 0 is going to be, now see. Okay, if you supply current here, it's not going to reach here at all. So 1 dot 0 is going to be 0. Similarly, 0 dot 1 is going to be 0, and 0 dot 0 is going to be 0. Switch whose state we are unaware of, such a switch are known as variable switch. Like at my house, there are 2 rows in the series. There are 2 rows in the switchboard. Third switch, whether it will be on or off, you will not be aware of it. Such a switch whose state we are unaware of is called variable switch. Now, such a switch are denoted by the variable x, y, z, a, b, c, p, q, r, etc., etc. We have to consider both the state for such a switch. For example, now, if I have a variable switch x connected to an on switch in parallel, let us see how this is going to work. I have a variable switch x connected to parallel on switch. If you supply current here, irrespective of the state of x, current is always going to reach here. So therefore, x plus 1 is going to be 1 itself, irrespective of the state of x. Similarly, what is x dot 0 going to be? So I have a variable switch connected with off switch in series. If you supply current here, however, whatever the state of x is not going to reach the current. So x dot 0 is going to be 0 itself. Now let us see what is x plus 0 going to be. Okay. If you supply current here, it's not going to take this path. It depends on the state of x whether it will supply current or not. That means it will supply current only if your x is on. So that means the diagram will look like x plus 0 is going to be x, and now x dot 1 is going to be, now let's see that. If x is off, this will not let current pass. If x is on, then only it will let current pass. So therefore, x dot 1 is going to be x itself. Now let us see x plus x. Now if that means there are two similar switch connected in parallel. That means if this is on, this also will be on. This is off, this also will be off. That means it will let current pass or not depends on the state of x itself. So this x plus x is going to be x. Similarly, x dot x is going to be x. The figure will look like this. Now let us see the new concept called complement switch. Two switches are said to be the complement of each other if they have the reverse state. Normally we denote the complement by dash or bar. That means if x is on, then x bar will be, or x dash will be off. Now let us see, when we have switch x and its complement x dash are connected in parallel, what happens? That means if this is off, this will be on, then it will let current pass. If this is on, this is off, this will let current pass. So in any way, x plus x dash is going to let current pass in any case. So therefore, x plus x dash is going to be 1. Very important. And what is x dot x dash is going to be? Think about it. Yes, it's going to be, now if this is on, this will be off. If this is off, this will be on. In any case, current will not pass, therefore x dot x dash is going to be 0. And you must know that complement switch, the complement is going to be the original state itself. Okay, so this is something which we are going to use in order to make properties and solve sums of the Boolean algebra. In order to solve sums, we are going to design some properties. So let us see properties of Boolean algebra. The first property which we are going to learn is called commutative property. It says x plus y is same thing as y plus x, and x dot y is same thing as y dot x. Let us see the next property called associative property. It says x plus y plus z is same thing as x plus y plus z, And the next one says x dot y dot z is same thing as x dot y dot z. This is called commutative property of plus, commutative property of dot, associative property of plus, associative property of dot. Let us see the third one called distributive property, one of the most important property, distributive property. It says x dot y plus z is x dot y plus x dot z. And little next one is very important one. It says x plus yz is same as x plus y dot with x plus z. Now some people says, sir, I mean, everything you say, is that true? This requires certain proof. What I am going to give you is little argumental proof about this property. We need to know, in a real number system or in a decimal system, there is a relation between plus and dot. Many times addition is called multiplication. Whereas here, plus means parallel circuit, parallel switch, dot means series, switches are connected in series. So there is no way, there is no combination between them. In decimal system, dot has given more hierarchy over the addition, you know the BODMAS rule. Whereas here there is no such rule. So how your dot gets distributed over plus, your plus also can get distributed over dot. This is a way to remember this property. And this is one of the most important property. In fact, almost all sums of board exams need to be used. Let us see, the next property is called absorption property. It says x plus xy is same thing as x, and it says the next one is x dot x plus y is same thing as x. Now this also requires proof. What I am going to give you is, I am going to give you two ways of proving this. The first, let us see left hand side. The left hand side is x plus xy. Now what I can do is, I can replace this x as x dot 1, which we have seen that x dot 1 is going to be x itself. Now you can take x common. If you take x common, you will get 1 plus y. And now 1 plus y, as you know, is going to, you have doubt about 1 plus y, let us see. 1 means switches like this, y means y switch is connected. That means irrespective of the state of y, this will always let current pass. So what is 1 plus y? Is going to be 1. So you have x dot 1 and which is going to be x, which is right hand side. So this is one way of proving. Let us see the next way of proving. Another way of proving this is called argumental way of proving. Now let us see what is this connection means. This connection means your x switch is connected to series or series of xy. What I am telling you is that the state of this switch depends on the state of x. That means if x is on, then only this will let current pass. Is that true? Let's see. If x is off, then there is no way current can pass. If x is on, irrespective of the state of y, it will always let current pass. So the state of this switch depends on the state of x itself. So therefore x plus xy is going to be x. Similarly, one can work with this out. This is all the same way. These two are called distributive property. Let us see the next property called De Morgan's law. Or De Morgan's property. It says x plus y the whole dash is going to be x dash dot y dash, and the next one it says x dot y the whole dash is x dash plus y dash. Okay. In order to solve any sum, we need to know all this property plus what we have studied in the beginning, that some property 0 plus 0 equal to 0, 0 plus 1 is going to be 1, etc. So now let us see types of sums which are going to come in Boolean algebra. What we are going to do is we are going to see one sum of each type. Okay, so now we are going to see types of sum of Boolean algebra. We are going to make use of all the properties and what we have studied before in order to solve sums. What we are going to do is we are going to list all types of sums and we are going to solve one sum of each type. Okay, now let us see the first type of sums. So what we are going to do is types of sums now. The first is simplify. Second, find the dual. Third, complement. Fourth, draw simplified equivalent circuit. Fifth, factorize. Sixth, zeros and ones method. Seventh is called word problems. Okay, we are going to start sums of simplify now. Let us see the first one. We have x plus yz, x plus y dash plus z dash. Our objective is to simplify this by using the properties of Boolean algebra. Now there are many ways one can simplify this. Okay, so let us see the first one. What you can do is you can consider this as two brackets and open this bracket by using distributive property. So let us see x dot x plus x dot y dash plus x y z, next y dash z, and the whole thing is dot with y dash plus z dash. Now if you have noticed, we have used two properties here. The one is called distributive property. And the next one which we have used is commutative property. And if you have noticed, what we are going to do is we are going to write x, then x dash, y dash, z dash, and that hierarchy we are going to follow. So if we have, see, if you understood, we have here y z y dash, and we have not written y z y dash, we have written y dash z. So that what I mean is that we are going to use commutative property always. Now let us see. What is x dot x? X itself. This x y dash, this x y z, and this is 0. So we have used two properties here. We have used x dot x is going to be x. We have used x dot x dash is going to be 0. And because of the absorption property, all this here is going to give me x plus 0. Sorry, I have missed this here. Going to be y dash plus z dash. What property we have used here is absorption property, or property or law, you can write. Then this is going to be x y dash plus z dash. So that's the final answer. We have used the property that x plus 0 is going to be x itself. Okay, so that's your final answer. So this is how we are going to solve sum of simplify. What we are going to do is we are going to make use of properties. One thing is noted that you have to write the properties or laws which you have used, otherwise board is sometimes cuts marks for these steps. It's very important to write this. So I suggest it's a good practice to write all the properties, whatever you use in every steps. Board require at least two properties. Okay, now let us see type number 2, dual. Question is, write the dual of expression x plus 1 dot y dash plus 0. Now what dual means is only one thing. Dual means whenever there is plus, you replace it by 0 dot. Whenever there is dot, you replace it by plus. 0 you replace it by 1, and 1 you replace it by 0. That's it. That's the end of it. So what is the dual of this statement? The dual of this statement is simply x dot 0 plus y dash dot 1. Finish. That's a dual. A precaution has to be taken. I am not saying that this statement here is equal to the next statement. What I am saying is the dual of this statement is this. That's it. Okay, don't get confused. I never said this and this are equal. Okay, the dual of this statement is equal to this. Finish. That's the end of it. Okay, now let us see type 3 category, complement. The question will always come as find a complement of P plus Q R dash. Now find complement of this. So what you can do is, there are two ways that the complement of this is meant is P plus Q R dash the whole dash. Now you can use De Morgan's law and you can write this as P dash dot Q dot R dash the dash, which we are going to use. We are going to use the property x plus y the whole dash is x dash dot y dash. Now you can use again De Morgan's law here and simplify this further as P dash dot Q plus R dash the dash, sorry Q dash, yeah, which is P dash dot Q dash plus R. Here we have used the property x dot y the dash is x dash plus y dash. Okay, so that's the final answer. One thing you must note that if you have x plus y plus z the whole dash, this can be written as x dash dot y dash dot z dash. Similarly, x dot y dot z the whole dash can be written as x dash plus y dash plus z dash. Okay, so this covers your complement types of sums. Now let us see the next type of sum called draw the simplified equivalent circuit. Now this is something which comes in board exam for 5 marks. Always 5 mark sums on this. Switch A is connected in parallel with B. B dash is connected to C in parallel. The whole thing is connected in parallel with parallel of BC, which is eventually connected with series of A dash, C dash, then there is going to be the load here or bulb, whichever they want. You may not light it, it's okay. Okay. So first of all, what we have to do is we have to understand what this circuit means in terms of expression. So first job is to convert this into expression. How we are going to do is, first of all, whenever this cover them up. Okay, so the first is A plus B, which is getting connected to series, that is dot, with parallel circuit of B dash plus C. Now the whole thing is getting connected to parallel with B plus C, which is getting connected in series with A dash plus C dash. Okay, so this is your expression, or we can write the functions f. Now with the help of Boolean algebra, what we are going to do is we are going to simplify this, get the final answer, and draw the simplified circuit of that. Let us simplify this. So we have here AB dash plus, I hope you remember that, what follow we are going to follow, b dash plus bc plus a dash b plus bc dash plus a dash c plus cc dash, which we have used is called distributive. Please note, this and this are going to get rid of in the next statement, is because we are going to use x dot x dash is 0 and x plus 0 is x. So we are not going to write even 0 because of this. So we have now ab dash plus ac plus bc plus a dash b plus bc dash plus a dash c. Now what we are going to do is we are going to collect like terms together. So we have AC here, A dash C here, BC here. So let me make this dark. Yeah, B dash C here. Okay, and let this to be as it is. So we have A B dash plus A dash B as it is. So we are covered with this as it is. From this and this we are going to take C common, and we are going to get A plus A dash. From this and this we are going to take B common, and we are going to get C plus C dash. So what we have used distributive again. Now we have this plus this, A plus A dash is 1, and 1 into anything is anything. So we are going to have A B dash plus A dash B plus C plus B. We've made use of two properties. X plus X dash is going to be 1 and X dot 1 is going to be X. Finally, B is going to absorb this because of the absorption property. So you can write B plus A B dash plus C. People think that that's a final answer, but that's not. What we can do is we can really use distributive property here. Let's see, B plus A dot with B plus B dash plus C. We have used distributive property. And B plus B dash is going to be 1. 1 into anything is going to be anything. So final answer is A plus B plus C. That's the final answer. We are going to write properties which we have used. X plus X dash is going to be 1 and X dot 1 is going to be X. Okay, so that's the final answer. What we have to do is we have to make simplify circuit of this. So that's very easy. Let's see. A here, B here, C here. Make this, draw if there is a lamp. Yeah, there is a lamp. So make a lamp here or bulb here. Okay, that's the end of it. So this is normally 5 marks sums in your board exam. Very important. Okay, make sure that you write properties well. Do not forget to draw the simplified equivalence and carries 1 mark final answer. Okay, now let us study next type of sums called factorize. Though the factorize is not given in most of the book, it is given only in ML Agarwal and Sultan Chand. It is not given in OP Malhotra. Though we need to cover this topic because some school asked this. Okay, so let us see few sums of factorize. We have to factorize AB plus A dash B dash. So our objective is to factorize this. Now let us see what we have done in Bachpan. X square plus 5x plus 4. Now if someone asks me to factorize this, then what we are going to do is we are going to write this as x plus 4 into x plus 1. This is called factorized form of this, and that one is called simplified. So basically it does exactly ulta work of that of the simplifying, where we are going to write terms in the brackets. That's the first objective. So that's what we have. What do you mean by factorize? So the property which we are going to use here is distributive property. We call it dual of the distributive property. That is x plus yz is going to be x plus y dot with x plus z. Now let us see. Consider this as x and this is y and z. So and use this property, you get ab plus a dash dot with ab plus b dash. Then one can use distributive again by considering this is x plus yz, x plus yz, and you can write this as a plus a dash, b plus a dash, a plus b dash, b plus b dash. And this is going to give you 1. If you don't understand, then you can make a circuit, x here, x dash here. If you supply current here, definitely it's going to reach on the other side. So therefore x plus x dash is 1, a plus a dash is 1, b plus b dash is 1. So these two are going to be 1. And you are going to have a dash plus b, as you know what we can write. And this is a plus b dash. So that's the final answer for factorized sum. Okay. Please note, if you expand this, if you open the bracket, you get the question back. So you have to leave the answer in this form. It's called factorized form of the given question. Let us see the next type, zeros method and ones method. Normally it will be a word type questions, like there are 3 judges and contestant will be selected only if there is a majority between them. And we have to design a circuit so that the final buzzer goes. So let us see, we have a judge x, y and z, and we are going to have conditions which are all possibility for a person to be selected. Okay. So we can have 0 0 0 0, 1 1 1 1, 0 0 1 1, 0 0 1 1. 0 1 0 1 0 1 0 1. Okay. Now all the 3 judges did not like this person, so he will not be selected because there is no majority. None of them press the buzzer. This 2 doesn't press the buzzer and Z presses the buzzer, so it's going to be 0. There is no majority. There is no majority. Yes, in this case X didn't like it, but Y and Z like the person, so they are going to press the buzzer. And yes, in this case we are going to have a majority, so person has to be selected. Again, no majority, yes, yes and yes. Here, very good case that all the 3 liked it, all the 3 pressed the buzzer and the final last person will be selected. How to design a circuit that the entire light goes off and on, goes off and on, something like that. So what we are going to do is we are going to use zeros method or ones method. So first we are going to take ones method. Objective is to mark all the ones. Please mark all the ones, and the switch which shows the state as 1, take it as itself. The switch shows 0 as a state, take it as dash of it. And please note, ones method is called SOP and zeros method is called POS. Now what I'll tell you what is SOP means. It's called sum of the product. So what it means, your function is going to be, see x didn't like it, so it's going to be, but there is a majority, so it's going to be x dash, y liked it, y is on, so it will be y, z. Please understand, SOP means you take the product first and then take the sum of it. The next one will be, so that add it to x, y dash, z. Next one will be x, y, z dash. Last one will be x, y, z. With law of Boolean algebra, our objective is to simplify this and draw the final simplified equivalent circuit. Till date, this is not asked in board exam, but still we are teaching this, called zeros method, ones method or word problems. together is this type. Okay. So now we are going to use the property. There is a smart way of doing this sum. So I am going to do the smartest one. X dash y z, I am going to write introduce x y z, plus x y dash z, I am going to introduce x y z. Then x y z dash, I am going to introduce x y z, which was already there. I am going to write this as, because x plus x is x itself. So I have used this here, here and here. That we can do. Next objective is to take yz common from the first, and you get x plus x dash. From the next two, you can take xz common, you get y plus y dash, and from the last two, you must take xy common and you get z plus z dash. So the final answer is yz plus xz plus xy. Don't leave this as answer, because we have to write here property x plus x dash is going to be 1 and x dot 1 is going to be x. Don't leave this as a final answer, because you can still take z common here. So z into x plus y plus xy is going to be the final answer, because this uses only 5 switches, whereas the previous one uses 6 switches, so you can save money basically. And your job is to draw a final simplified circuit. So let us do that. You have z, which is connected in series with parallel of x and y. The whole thing is connected in parallel with x, y. So that's a final simplified equivalent circuit. Let me check that once again. Yeah. So that's the end of it. That's the end of this Boolean algebra topic. This topic, what we have done is just give an overview of the entire topic. This is the end of this topic, Boolean algebra. What one must have to do after learning this summary is study this topic for 2 hours. More difficult sums will be tackled in the class. Okay, that's the end of this topic.